The p-value is also used as a decision rule instead of comparing a computed statistic to a critical statistic. Note that both the computed statistic and the critical statistic are points on the horizontal axis of a distribution. The p-value is an area in the distribution which corresponds with the computed statistic. The significance level alpha is also an area in a distribution that corresponds with the critical statistic. As a general decision rule, we will reject the null hypothesis if the p-value is less than the stated significance level. When the p-value is smaller than the significance level, this means that the computed statistic is within the rejection region of the distribution. Whether we are using the p-value or the computed value as a decision rule, the conclusion we make should always be the same. This is an example of how we can use the p-value as a decision rule. We recall the problem wherein we wanted to test whether the mean number of desks assembled in the last 50 weeks was more than 200. The hypotheses are again shown on this slide. In that problem, we determined the computed z-statistic to be positive 1.55. Because this is a right-tailed test, the p-value is the area to the right of this computed statistic. Using the standard normal distribution table, or you can use an Excel function, we obtain a p-value of 0.06057. Because the p-value is not less than the significance level of 0.01, we will fail to reject the null hypothesis. Note that this is consistent with our conclusion when we used the computed z as the decision rule in a previous example. We show in the next slide how this p-value is obtained using the standard normal table. We show here how to obtain the p-value for a one-tailed test given a computed z-value of 1.55. On the distribution curve shown on this slide, we find the area from z of 0 to z of 1.55 as 0.4394. Remember that the p-value for this one-tailed, right-tailed test is the area beyond a z of 1.55. As such, this area, the p-value, must be 0.5 minus 0.4394. It is 0.0606. The p-value can also be obtained using the Excel function listed at the bottom of this slide. So what does it mean when the p-value is less than alpha? In particular, what does it mean when the p-value is less than a large alpha such as 0.10 or a smaller alpha such as 0.05 or 0.01 or 0.001? The magnitude of the p-value is an inverse indication of the strength of the evidence the sample represents in rejecting the null hypothesis. Simply put, the smaller the p-value, or the closer it is to 0, the stronger the sample represents as evidence in rejecting the null hypothesis. So when the p-value is less than the significance level of 0.10, we have some evidence that h sub 0 is not true. When the p-value is less than the significance level of 0.05, we have strong evidence that h sub 0 is not true. When the p-value is less than the significance level of 0.01, we have very strong evidence that h sub 0 is not true. And finally, when the p-value is less than the significance level of 0.001, we have extremely strong evidence that h sub 0 is not true.